All right, so the goal of this video is to get an understanding of how we can add conditional statements into loops. All right, and by conditional, we mean to be able to check if a condition is occurring and maybe, direct the program to do a certain type of logic based on that condition. All right, so let's just look at some basics, right? So this video should be relatively straightforward. So let's just look at a very, very basic loop. So we'll say something like for number in range, and let's go 1 to 11. And if you remember the way range works, it includes the starting number. So from 1, and it goes all the way up to whatever we specify as that second or stop number, but it doesn't include it. So if I were to print number there, all right, so we get the integers 1 to 10. Now let's assume that we want to print out, or we want to check and see if integers, the current integer in this loop is an even integer. And if it is, we want to print something out. Otherwise, we don't want to do anything. All right. So we can use an if statement to do this. Now, up to this point, we've seen these loops and we've got a for. And we know for each step in this loop, what we want to do is print that number. So we had this white space here. Well, we're going to start to get more nested white space to kind of control the flow of this program. All right. So first, let's say, well, if, all right. So notice I hit that enter, that colon, it by default brought me down there. So that is essentially 4 spaces or a tab over. And I'm going to say, well, if number, and I'm going to take the modulus operator over 2. So I'm going to essentially say, okay, well, let's divide it by 2 and see what's remaining. And if there's nothing remaining when I divide it by 2, then that means it's an integer number, or an even number, I should say, an even integer number. All right. And what we need to do is now, because we only want this print statement to occur if it is an even number, what we need to do is then nest that print statement underneath it. All right, we'll kind of just look at the cases where we do and we don't, but this is the correct syntax. So we're iterating over that range, and then we're checking if this condition is true. So if the remainder after we divide by 2 is equal to 0, then we want to print something. All right, and what we're going to print is we'll say, all right, we found an even number, and I'm just going to put it there in parentheses. All right. So you can see when that loop gets to the variable or the number 2, it says, hey, I found an even number. When it also does that when it goes to 4, 6, 8, and 10, as we would expect. Now let's see what would happen if we would have not had that print nested underneath. This is actually going to give me an error. All right, because it's saying, hey, I expected an indented block. So if you're saying if something, right, and what do you want to do? If you're saying, well, I'm checking a condition, you're doing that for a reason, and you did not specify what that reason was. So you didn't give me anything to do if that condition is satisfied. All right, so we can say if, and then we nest that under. All right. Now we could have a lot of different cases, right? So instead of just looking for, even numbers, maybe we want to just iterate and just figure out, are these things even or odd? So in this case, we could say, well, if the number divided by 2, if the remainder is 0, so that's what that's capturing. Well, if that's true, we found an even number. Else, right? So that's another that you can put in this logic, another statement. Else, so if it's not even, it's an odd number. Whoops, had that on my clipboard apparently. All right, so if that's true, we want to print found an even number. Else, we want to print we found an odd number. All right, so in this case, 1 is odd, 2 is even, 3 is odd, and so forth. All right, so we can use if and else, and we can also use there is also an elif, right? So we can make this really, really kind of nested. And again, I'm just going to show you, this is a really kind of contrived and simple example. We would definitely encounter much more complex use cases of this, but just to show you, we've got if and else, and we also have an elif, right? Because there could be multiple things. Well, if this happens, do this. If this happens, do this. Otherwise, do this, or else do this. So I'm just going to make a letter. And again, this is not the best way. There's much more Pythonic ways to do this, but again, just to kind of demonstrate how you can kind of check and see if a letter matches a particular case. All right, so I'm going to make a thing. I'm going to say, well, if the letter equals A, what we'll do, I'll print, and again, this is very verbose. Let's print letter it's A. All right, and I'm just going to copy this down a couple of times. All right. Instead of saying, well, if, you can do elif letter is B, all right, and you get the picture. So we can check letter is B. Whoops, letter is C, sorry. And so forth. I think I made too many. So we'll do one more, elif letters D. And then finally, if none of those conditions are matched, we can do an else print letter is not A, B, C, or D. All right, so this is a structure if you have multiple types of conditions you want to check for. So in this case, it's looking if letter is A, do this thing, letter B, C, or D. And then otherwise, if none of the previous conditions are matched, it will execute the else statement and to say, hey, it's not any of these things. All right, so if we look at this, letter is A. So if we go to C, all right, so the letter is C, and so forth. And then we can say an else, we'll print letter is not any one of those. So if we were to give it a G, letter is not. Now, one thing to note is when you're setting up these conditions, it's actually important to kind of think through. So it could be that you're working with a data set where one case is going to happen 95% of the time. Okay. And then in the remaining 5%, it could be a multitude of things, right? So, you know, maybe 95% of the time the letter is going to be A, but every now and then it could be B, C, or D. All right. Well, you want to make sure that you structure your setup here where the most common is towards the top. Now, you might not know what the most common is, so don't really sweat that if you don't. But if you do have some insight onto what's going to be the most common condition that's going to be satisfied, it would be better to have that towards the top. And why is that? Well, when Python is checking these conditions, it actually does them in order. So like with this letter is equal to G, it's going through and it's saying, well, okay, first check, is it A? It's not. And then now I'm going to go do another check. Is it B? It's not. Is it C? It's not. Is it D? And then it's going to finally go to this else block. Okay. However, when the letter is A, it's going to check and say, well, if the letter is A, that passed, that's true, ignore everything else. So if you've got your most common condition, at least, you know, if you've got some intuition or some insight into what that most common condition will be, probably better to put it first, because if you're executing this tens, thousands, millions of times, you want it to, you know, hopefully if you've got the most common thing first, you're going to be able to exit that stream of logic a lot quicker, right? So a lot of times it's going to hit that first case and it's going to exit, and that could save you some, you know, some computational time. And just depending on how, you know, in this case, we're just looking, hey, is this thing equal to this? But you might actually be checking, you know, some type of a mathematical or some type of a mathematical expression, right? That could be computationally expensive. And you don't want to check a bunch of computationally expensive things just to get to the most common case at the bottom. So do that at the beginning. All right, so that is going to conclude this video, and we will continue on with another short video looking at a recent addition to the Python programming language, which is the walrus operator.